You might not think of chemistry when you're baking a cake, but in reality, all those ingredients that you put together undergo lots of chemical changes in order to make that delicious cake in the end. Most baking involves flour. Flour is usually derived from wheat or nuts or something like that, and is ground down into really small, powdery substance. When we add water to flour, that flour, the proteins inside that flour start to bond together, and it makes something called gluten. Gluten is a protein that actually helps keep the cake together, help keep whatever you're baking together, and it kind of fits together. Now, some people are actually allergic to gluten, so they can't use flour in their ingredients. They typically look for other things that they can use instead of flour. But the idea of gluten actually is a protein that that is created by a chemical change when you add water to the flour. Cakes, cupcakes, even cookies, pancakes, all of these things are light and fluffy. They actually have a gas inside of them that actually raises them up and makes them light and fluffy. We know what this gas is. It's called carbon dioxide. Carbon dioxide is created when baking powder or baking soda react with the dough, and they actually make little bubbles. Baking soda actually reacts a couple of times. It reacts right when you put it in with water. It'll make some slight different bubbles. And then it also reacts once you get it up to about 300 degrees. It'll react with the dough and make those carbon dioxide bubbles. Those bubbles then bubble up the dough, which makes it light and fluffy like you would have in a cake or a cupcake. Another way to do this is actually with something called yeast. Yeast is actually a living thing. It's a fungus that we put in. And that fungus actually eats some of the sugars that's in the dough, and it digests it. And just like us, when we bring in oxygen, we mix it with the sugars that we eat, and we breathe out, they also breathe out carbon dioxide. That carbon dioxide also makes the cake light and fluffy. So either baking soda, baking powder, or yeast actually is called leavening agents, which make it nice and fluffy and ready to eat. Sugar actually does a lot more than just keep this thing sweet. It actually undergoes a chemical reaction called the Maillard reaction. This reaction allows it to actually brown on the inside. It gives like the outside of toast, how it has that brown part on the outside. That's called the Maillard reaction. Or even the outside of a brownie or the outside of a cake. So it forms that outer layer which holds some of the moisture on the inside. So sugar, even though it does make it sweet, it's also involved in other chemical reactions that help make the cake delicious. Other than sweetening it and the Maillard reaction, we actually use sugar in other ways in baking. We can actually do what's called Carmelization. If you take sugar, sprinkle it on the top of something, like maybe a creme brulee, you will see a chef actually take a blowtorch and burn the sugar right on top of that. You may have burnt some sugar when you're making marshmallows for s'mores on a fire. But that caramelization is actually a burning reaction with the sugar. And then it creates a really kind of a fine butterscotchy type flavor on top of whatever it is you're trying to do. So we use sugar in lots of different ways when we bake. When we add eggs to our cake, we actually tend to beat the eggs, right? We tend to take this and beat the eggs around like this. And what we're doing there, the eggs actually serve a couple of different purposes. One purpose that the egg actually does is it holds the cake together. It's called emulsifying. It keeps the kind of ingredients stuck together and keeps them from falling apart. But another thing that the egg does as you beat it is the egg white actually creates a protein which surrounds air bubbles inside the baking ingredients. so that when it cooks, those air bubbles are still there, and it also can make it light and fluffy. So we use eggs for a couple of different purposes. All right, so there's chemistry all around you. I can't wait to see how this chemistry works out. I'll see you next time.